Okay, so here a cigarette manufacturer wants to see if the nicotine in his cigarettes is as advertised, which is 1.5 milligrams. They take a random 36 cigarettes, and they find that the average in those cigarettes for nicotine was 1.62 and a standard deviation of 0.2. Okay, we want to see if the amount of nicotine is equal to 1.5 milligrams. Again, equal is the equal sign. So here what we're testing is mu is equal to 1.5 versus mu is not equal to 1.5. Again, here, equal to. The equal sign has to go into the null hypothesis. It must. If there's only one possibility, that's where it goes. Therefore, the alternative is not equal. We're not necessarily testing if it's larger or smaller, just if it's equal to or not equal to. Okay, so using the data, we find the test statistic to be 3.6. The degree of freedom is 36 minus 1, or 35 degrees of freedom. When you go to your t-table, this is a little bit why t-tables aren't the greatest, but on your t-table there's only 30 and 40. There is no 35. Okay, 30 and 40. So which one should we go with? You should probably go with the one that's closer to, or in this case, it's closest to either of them. So always go with the smallest of the ones of the possibilities. So here we're going to look up the test statistic, which is 3.6. Try and find it in our table. Here we go. Here it is. In between here and here. In between 3.3 and 3.64. Okay, so I know that the p-value, or at least half of the p-value, is in between 0.001 and 0.005. Okay, so here that's what I've shown here. It's in between these two. If you had selected 40 degrees of freedom instead of 30, then here the largest value is actually on the table is actually 3.5. So here, if you went with 30 degrees of freedom, then you're saying that half of the p-value is in between this and this. If you're going with 40 degrees of freedom, then you're saying that half of the p-value is smaller than this. Okay, so here half of the p-value is in between these two, so we'll just multiply each by 2 and find that the p-value is in between 0.001 and 0.002. Okay, this is very small. This is a very small p-value. So here, 0.001 to 0.002 is definitely smaller than 0.05. So we will reject the null hypothesis. Okay, we're going to reject this idea, and instead we will go with this idea. Based on this data, it appears that the mean amount of nicotine is not significantly close, or is not significantly equal to 1.5. Again, we didn't test any sort of relationship here, so we probably shouldn't comment on any. Let's see what happens when we do this in Minitab. Going to go to Stat, Basic Statistics. This is a one sample T, where the sample size is 36, and the sample average is 1.62. The standard deviation was 0.2, and the hypothesis was 1.55, and the sign in the hypothesis was the not equal to. Okay, so here you can see they do actually, something about this doesn't seem right. Did I mess something up? Let me have a look again. 36 is the sample size. Standard deviation 0.2. Oh, the hypothesis wasn't 1.55, it was 1.5. There we go. Okay, sorry about that. There we go. My test statistic is 3.6, and my p-value is 0.001. Now, what you need to know is, when you're talking to Minitab, you don't need to multiply what they give you as a p-value by 2 because it's two-tailed. Okay, so here you don't have to worry about the multiplying by 2. When Minitab does it, you've told Minitab what the sign is. It is just telling you the p-value. It doesn't need you to do anything other than to just read it. So the p-value is actually 0.001, okay, which I guess, is very close to in between these 2 points. Okay, so here, when you're doing it by hand, you have to do the multiplication by 2 when it's two-tailed. When you're using Minitab, you do not have to. As long as you told Minitab that it was two-tailed, it has already done that for you. The other thing to note, because we've got a two-tailed alternative, we get a confidence interval instead of a confidence bound. What does this say? We're 95% sure that the interval is between this and this. This is where we believe mu to be. As you can see, here's where I've got my 1.5 screwed up. 1.5 is not inside the bound. In fact, the bound is completely above it. So you can infer that the mean is actually larger than 1.5. Maybe another question that somebody could ask you is, if you made an error here, what type of error did you make? Well, here I've rejected the null hypothesis. That's what I've done. Okay, I rejected the null hypothesis. However, the null hypothesis may have been true. Maybe my data is just weird and rare data. Okay, so maybe I rejected the null hypothesis, but the null hypothesis was actually true. That would be a type 1 error that was possible. I possibly made a type 1 error here. I'm not sure if I have or not. The chance that I've made a type 1 error is 5%. It's a 5% chance I have made a type 1 error here.